Hi, good afternoon, everyone. This is Eric with BobCAD Tech Support. I'm normally doing the demonstrations of the software program and also doing tech support with BobCAD. So answering any questions in tech support and also doing demonstrations of the software program with our standalone version of BobCAD version 35. We also offer a plugin for Rhino. We're up to version 2. Uh, second version of BobCAM for Rhino, and also what we're going to be looking at today, which is version 10, BobCAM for Solidworks. So we'll be looking at the 4-axis milling module today, and today is going to be 4-axis standard package. Next week we'll be going through the 4-axis pro package. So we'll be looking at the difference between the two, what you can do in what you can do in the 4-axis standard versus what you can do in the 4-axis pro, and then get more into the technical side of the 4-axis standard package, how to create a milling job, set it up with your work offsets, define your stock, your workpiece, and your geometry for each milling operation. We'll be going through indexing, be going through rotary operations, and also we'll be going through wrapping group operations if we wanted to do a pocket around a cylinder, or maybe an engraving around a cylindrical part there. Most commonly with a rotary table. We'll be looking at that today. And we'll be getting started in the next minute or two. Just want to make sure that you guys are able to see my screen and able to hear me, and we'll get started here. Also wait for anybody else to filter through here. So Mark, good to see you in the chat here. Can you include methods to use the side of the end mill on the rotating part? Yes, I remember we did a webinar somewhat recently with your question in there. Yeah, I remember we have the side shift option, and we'll be taking a look at that today. Methods to use the side of the end mill on the rotating part. I believe I got it answered last time in our standalone version of 4-axis. So yeah, we can take a look at that in our the options in 4-axis milling for Solidworks today. It's going to be the same method, but I will get into that today. I believe it's not the side shift option like we saw last time. I kind of got it figured out last time where you wanted to see indexing and then using the side of the tool to use after indexing, rotating the part around a rotary table, and then using the side of the tool for like a profile on the side of the part. Let me know if that's what you're interested in looking at today. I think that's what we saw in the standalone. We'll take a look at the method of doing it here in SolidWorks. It's going to be the same workflow, but we'll still take a look at it and answer any other questions that you guys have there in the chat. Please let me know. And we'll get started here in the next couple minutes. Yeah, sure. We'll take a look at those options there using the index, using the side of the tool. And we also have the side shift option where you can use the side of the tool with a rotary operation. So the part can rotate around the whole time with using the side of the tool more than going straight down, having the tool point straight down in the towards the rotary axis the whole time. And in the chat, we also sent a link to some of the things we're going to be going over today, and some of the new settings in version 10 for SolidWorks, where we have automatic recognition of drills, so that you can, with the whole recognition setting, you can select different. You can select a solid model, and it'll pick up the holes along the part there. Some settings for open pocket that you can set, and some things in 4-Axis Pro going down in that link as well. So we'll get started here in just maybe 2 minutes. I'll answer this question for you, Mark, and then we'll get started. Waiting to start with the new 3-year license support rules. What will be the procedure for moving older versions to a replacement computer? So what you would do, since I just have SolidWorks here on my screen, well, I guess you could see it here as well. You could go to help, or do we have the help setting here? I know SolidWorks 2023 is a little new. Okay, yeah, so help is over here on the top right corner. This question mark. Then you can go to BobCAM help. You can go to transfer license. You would transfer the license of your older version of BobCAM for SolidWorks automatically via the internet. You just type in your license ID on the next page here, and it will transfer the license. Then you can go to SolidWorks on a new computer, and then go to activate license. You would type in that same license ID and password from your invoice. That license ID and password does not change. So yeah, good point. You can always transfer your license and move it to a new computer whenever you want to there. Nice. And we also have a link in the chat, so you can reference that later on how to transfer a license as well. Yeah, so let's get started here. Make sure I got my screen sharing, got everything going on here. We'll take a look at 4-axis demos here. All right, so we have a part here with 5 different sides that will need to be milled with kind of a cylindrical shape here, you could say, and the x-axis of rotation will be going through this surface here with our. We'll be setting it up with an a-axis rotation. So we'll probably want to start with like a facing operation on this side. Then we'll be doing the 3-axis roughing, facing and pocketing on this side, and going all the way around. And to do that, we can start by going to our cam tree that loads in when we install BobCAM and get it registered here. So just as you would have your feature tree and all of the other trees here in SolidWorks, you tab over to the cam manager or the cam tree. You can right-click on cam defaults and go to a new job. You have your different job types here. You have milling, turning, mill turn for a lathe with live tooling, and wire EDM operations there. In milling, just as a side note, we also offer laser, plasma, and water jet machining as well. We have our BobCAD 3-axis mill. I'll select the BobCAD 4-axis mill that offers rotary milling operations with a 4-axis mill with the A-axis. So that will be going around the X-axis. We'll click OK. We'll select our workpiece, and all of these this workflow is going to be the same as a workflow for 3-axis milling or any of your other milling setups here. So you select your workpiece. Our next page is where we can define our stock. So it comes in as rectangular stock normally. We'll select cylindrical stock. And we want the extrusion direction instead of the Z-axis down here. We want it going through the X-axis. And right now it's a bounding box, so it'll just create the smallest cylinder possible to hit all of the surfaces of the part. Or I can select bounding cylinder normally, and that will encompass a cylinder around the part file there. Our next page is where we can define our machine setup. This is where we're defining our work offset, or our G54. And so if we're setting our G54 with the rotary axis right here, I would click that point. And I can change my Z-axis, like say for example if it's starting like at that point and then we'll be rotating around, we can kind of do that. And then we'll click OK. Going back to that machine setup, I can right-click on it, right-click on Machine Setup 1 in the CAM tree and go to Edit at any time if I needed to modify it. And just as a side note, the machine setup can be defined very similarly to a coordinate system in Solidworks. You can actually pick from an existing coordinate system in Solidworks with this pick from existing UCS. You can also pick the X, Y, and Z axis the same way as you would in SolidWorks. So you saw I highlighted this Z axis and clicked on a point or a line parallel to the Z axis, and I can also reverse the Z axis so it'll flip the direction there for these arrows as well. So just the same exact way you would create a coordinate system in SolidWorks is how you would create the coordinate system for your machine setup or for your G54 work offset there. So we'll right-click on the machine setup next. We have our different milling operations. We have drilling and tapping, counterbore operations, our 2-axis milling, our 3-axis milling, 4-axis rotary, which we'll be getting into next, but for this one we're going to be indexing. So to kind of get the understanding here of the 4th axis, we can see our Z-axis pointed up. So this is, maybe we could do like a 3-axis milling operation to do this, to get down to this face with a ball end mill maybe, and maybe a 3-axis operation, and it would come down and get some of this area. It'll get some of the inside of the pocket here. Definitely wouldn't reach down to the bottom of the pocket here with a 3-axis milling operation. So we'll want to use 4-axis. So to rotate around this way to get to here, and just use a flat end mill for a facing operation very easily there. And then rotate around, do a 3-axis milling operation to get all the way down inside of the pocket here. Go around and do the facing and the pocket operation. And so to rotate around and lock the rotary axis to this location, again, we can create an index by right-clicking on Machine Setup 1, going to Additional Functions, and going to Add Index. So it'll create an index system down below the Machine Setup 1. I can right-click on it and hit Reselect, the first option under Index System. So normally, yeah, from what I was remembering, it will want a planar face. So it will want you to create a plane first to use as the index. That's the easiest way of going about this. So I remember with the creating the features, I do have it in a SolidWorks part file I could go into, but I think we should maybe explain it a little more here of how to create that reference geometry in SolidWorks. So we go to reference geometry. So that's under features in SolidWorks. Go to reference geometry and go to plane. And I can either easily, I can select the face as my first reference point, select a line or a point. Well, actually, I might have to do something different there. Okay, so first reference point, I think the easiest way is just selecting 3 points for your 3 references here. So first reference, you just click on the points there on the corner. Second reference, you can select the second point here on the next corner there of this edge. If I can get it, there we go. Looks like it might be defined already, but just to make sure, we'll hit the third reference with this third point on that point. Okay, now it is saying that it's fully defined with this message, and I can hit OK. Now we've got plane number 1, and that'll be in your feature tree in SolidWorks that you can select for your first index. Again, we went to features, we went to reference geometry and plane. I selected these 3 points along the surface here to create plane number 1. And that way in SolidWorks, you can create a plane and then you can sketch on here. So if you want to do any sketching and do an engraving or sketching and create a pocket like this here, or create a feature like this extrude boss, you could do that from this plane on this surface. But more importantly, we're going to be going through creating an index from that plane. So I'll start from the beginning with this one here. If I can delete it. There we go. So again, from our machine setup in BobCAM, in the CAM tree, I can right-click, go to Additional Functions, go to Add Index. Creates an index system from the machine setup that I can right-click and reselect. Select my plane. And now you can see this blue arrow instead of my z-axis pointed somewhere through this top point here. It will have our z-axis pointed in this location for our tool to go down, up and down in this z-axis to do a facing operation on this top face here. So I hit OK. We've got our index system created that I can right-click on and do my milling operations from that index system rather than the original machine setup. So I right-click on index system, I go to mill to axis, select my geometry, so I can select the surface there. Actually, do we have a facing? We do have facing, sorry. So we could either do it from the mill to axis, or we can select facing, and that'll select the geometry. It's more of a smart feature there. Sorry, so we right-click on index system and go to mill facing. It picks our geometry up automatically from the feature. I can select my geometry if I want to, but it's more of a smart feature here. It'll understand the geometry I want to pick up. I can pick the top of the feature and then pick my total depth. Looks like it has it there automatically. My next page, got the facing operation in our current operations list. That looks good. Hit next. work offset number. Number 1 is our G54, 2 is G55, 56, and so on. Next is our tool. I'll go into the tool library and select a larger tool for the facing operation. I'll sort by diameter by clicking on diameter up at the top of the tool library and click on it again so that the larger tools are up at the top. And I'll do a 2-inch face mill and click OK. Click OK again in the tool crib. So now we've got the 2-inch face mill, we've got our feeds and speeds here, we've got our tool number. Our next page, whether we want to zig just going one direction, zigzag going back and forth. We also have an adaptive toolpath. This is a newer option in the facing operations. This is a high-speed machining option where it will continually spiral around the surface, keeping constant tool engagement here. I'll do the zigzag just so we can see it, kind of follow along more easily. With the zigzag, set our step over amount, set the first cut offset here. The distance off of the workpiece, so it'll move off of the workpiece a quarter of the tool length, so you can see this linking, it'll move off of the workpiece a quarter of the amount, or a quarter of the tool. So they're going, I believe it's a quarter of the tool, so it'll be half an inch, a quarter of 2 inches, or a half inch off of the tool, move over, and then move back over off of the tool for the next pass. We have our start position, our cut direction, it's moving back and forth in the x-axis. So all of your settings here to set up your facing operation exactly how you want. The distance off of the workpiece for each pass, your step over, your start position, and your direction of the facing operation. And our next page is a bottom allowance. So if we're doing one facing operation here and then a finish pass for a facing operation, we can leave a little bit of material for the finish pass to clean up. We can do a single step down or multiple steps down and set a depth of cut for each pass. I'll do 2 number of cuts here. A lead in and a lead out. So if I want to start with a lead in first and set the length, and the lead out and set the length there. Linking, so if we want to do a direct link or an arc around each pass. Advanced feed rates and MDI, these are a couple newer pages here in BobCAM for Solidworks. Advanced feed rates is where we can convert rapid moves to feed moves. So if we're not able to set a rapid rate at the controller, we can convert the rapid moves to feed moves and set the feed rate here to change that rate for our rapid moves, where it's rapiding back and forth and where it's rapiding from tool changes, things like that. We can set our feed rate for our lead in and our lead out. And our last page is MDI for manual data input. So if we wanted to output for different various G&M codes, change the spindle speed, change the work offset here, we could set a dwell time in between tool changes. We can also add any raw text. So any comment we wanted to add before or after an operation, I can add that command here and then type in, if we wanted to, we'll highlight after the operation, I wanted to add this command, and enter if we wanted to add it as a comment, so it'll add the parentheses for us, or any raw text. I'll type in comment and type in this is a test comment. Try to find it there in the G code for us. Comment there. Then we'll hit compute. There is the tool path for the first facing operation. We can backplot it by right-clicking on facing and going to backplot. And we can step through it. It'll move back and forth. And then go to the next position for the next pass. I'm going to change down at the bottom right corner of Solidworks. I'm going to change it from millimeters to inches. Much easier for me to do that. And then we can go about doing the next indexes around here. So what I can do next is I'll create the next plane. We'll do the 3-axis milling next, where I can go to Features in SolidWorks, go to Reference Geometry, go to Plane. Yeah, it's easier just to select the points here along the top face of this here. So we select the points along a flat surface here and click OK to create plane number 2. Auto update the cam tree. No, we don't need to do that. We're just creating new reference geometry here for plane number 2. And to make the next index system, I right-click on Machine Setup 1, go to Additional Functions, and go to Add Index. Add Index, Index System. That I'll right-click on this second index system in the cam tree and go to Reselect. I'll click on the plane. I could also click on the plane from the feature tree right here at the top. I can drop this down and select plane 2 here as well. Just to show you that BobCAM for SolidWorks is fully integrated in SolidWorks by selecting the feature, dropping down the feature tree and selecting any kind of geometry in here for any of our milling operations. So for indexing, we can select the plane here, or select the plane here inside of the SolidWorks part file or SolidWorks assembly file, so that if we have any kind of feature like an extrude boss or an extrude cut or a sketch that we want to select, we can select it from the feature tree specifically here. So I'll select plane 2 and hit OK. Now in that index system, with the reverse option, it'll set the arrow to go down, which is not what we want. So if it is going down, we would hit reverse, and we want the Z axis pointed up for the Z coordinates to be in the positive direction of how we need it. So if it is pointing down the way you don't want it, you can just hit reverse here to change that. All right, so we can right-click on the next index system and go to Mill 3-axis. Select our geometry. So as we explained in the Mill 3-axis Standard and the Mill 3-axis Pro V10 BobCAM for SolidWorks, the last 2 weeks that we had these webinars, we were explaining the geometry selection and boundary selection to contain our tool path in a certain area. And with our geometry selection, we are normally selecting whole bodies. So we check the box, select whole bodies, because we're normally selecting everything here within the part file or everything here within the assembly file to make sure that if there was any kind of obstruction, so for example, if there was any other kind of boss here, excuse me, voice crack. If we were to select any sort of obstruction, like an extrude boss that is that would obstruct or interfere with the tool linking or tool milling here and could cause some kind of gouge, we would want to select that to make sure that BobCAM recognizes that to avoid the areas there of any obstruction. So for example, if we had a clamp in between this area here, we would want to select that here in the geometry selection to make sure that the tool avoids any collision there. So that's our select geometry option, and then our select boundary option, where we can. I'm just going to click on these 4 edges of this surface because we're containing the toolpath inside of that area. We could more easily select a boundary with surface edges if I clear the selections here. We do have a chain selection option where I can right click on a surface edge. We have our select loop option. So it'll select the loop of all of the surface edges of a surface. So I'll click OK, go to my next page, set my top of feature, set it here at the top. My next page, we have our 3-axis roughing three-axis milling operations. So in our 3-axis standard package, we offer Z-level rough, Z-level finish, planar, going back and forth across the surfaces, spiral, radial, and plunge rough. And then these are our 3-axis pro operations. You can see the Z-level rough versus the Z-level rough versus the advanced Z-level rough. You can see it'll start from the outside of the stock for a side roughing routine. Some other features that it offers, high-speed machining options to keep constant tool engagement. We have a rest machining option in there. A lot of features to cut down on cycle time at the machine and also cut down on computing time as well. So we'll use an advanced rough operation to start with, and then we'll do an advanced Z-level finish following along the tapered walls and things there. Or actually, maybe since we've got flat areas, we could take a look at our new feature here in V10, steep shallow. Let's take a look at that. The other 3-axis pro operations we offer: flatlands to mill any flat areas on the part with a flat end mill, equidistant for a spiral tool path, giving us a better surface finish there, pencil to mill any fillets, project curves to project a 2D shape onto a 3D surface for a 3D engraving operation, and planar to follow along back and forth along the surfaces there as a finish pass. We'll be taking a look at the steep shallow. So in our current operations, we have the advanced rough and then our steep shallow operation. And then our next page, we can set up our work offset. Next page is for multi-axis post. This is how it'll post for the multi-axis for the 4th axis there. We set all of this by default. We don't have to change anything in there. And then our next page is our tool page. I don't want to use a face mill. I want to use a smaller tool for this one. So I'll go to my tool library and I'll select a sort by diameter. And normally I have a 1/2 inch. We'll do the 1/2 inch flat end mill. Highlight that and click OK. Click OK. Got our feeds and speeds. Our next page, we have our different cut patterns. So we'll do adaptive roughing. This is our high-speed machining option. Versus like parallel, we have zig or zigzag back and forth across the part. We could start from the center and offset our way outward, start from the outside and work our way in. This is stepping over each time, which would take time to step over and not machining anything. Then we have our morph spiral and adaptive roughing, where we have spiral toolpaths, so it's going to be constantly engaged in the material the whole time. With this one is our tricoidal milling, so you can see these linking options in yellow is going to rapid instead of step over with a feed rate. It's going to rapid across to the next pass. So again, adaptive roughing and morph spiral are the faster toolpath milling options there. It's going to cut down on your cycle times with constant tool engagement. Our next page is our depth of cut and step over amounts. Maybe I'll double this. Instead of 100 thousandths for each one, I'll do 200 thou for each depth of cut and for each step over. And an allowance option, I'm leaving 10 thou for the finish pass to clean up. Whether I want to plunge, ramp, or spiral into the material entering into the stock. I don't want to go down into the stock though, so I'll go back to plunge, and instead of it plunging down to start, we do have this center cutting tool option. So if I uncheck this box center cutting tool, it'll start from the outside and work its way in. Next page, we explain the rest machining option here. So if I had a previous roughing operation, I can tell the software the previous tool diameter and the previous tool corner radius, and that way the software will calculate the previous tool, and any areas the previous tool couldn't fit into, it'll calculate only that tool path for us. So essentially, it'll start from right where we left off from the previous operation, and air cutting.
How often do you run into that, Eric?
Yeah, good question, Al. Got Al in the chats also, or with the microphone. That kind of surprised me. So, okay, so with the rest machining option or rest roughing, yeah, good question. I mean, with customers, with a lot of demos that I do, we do get a lot of feedback with this. So customers will use previous tools, or for example, like with a casting uh, or with previous operations. Say for example, uh, from my experience with customers, they will have like one programmer and they will have it machined with a certain tooling that they have designed, and then if they want to go back to the SolidWorks part file here, for example, they can use a new tool based on the previous tooling that they've used, and then calculate just the tool path that they need to for this specific tool after the fact, basically. So after milling operations have been done, and they want to go, I guess you could say, back to the drawing board, or back to programming with new tools, they can set that up and
So what I want to do here, Eric, is I want to jump in real quick
sure.
because there's a topic that's on one of the groups, which has to do with roughing a tooling shape like this. Have you ever worked with any customers that make custom tooling and they're using their fourth axis to cut pockets on the different flutes for the tool?
Uh, Different flutes for the tool. No, not that I can think of.
Okay, so in our one of the communities that we have besides our forum
Yeah.
is we have our Facebook groups, and in one of the Facebook groups there's a question about this currently,
Okay.
and the user is using adaptive roughing to come in and to machine this part, and basically what he's trying to figure out is how to limit where he's cutting, right?
Mm-hmm.
And control where he's cutting and where he's not.
Okay.
So he's using advanced roughing. What are some things that he might use in order to control where he's cutting with advanced roughing?
Some tools that we can use. So, like with your part file that you have there, it looks like you're doing like an open pocket on a couple of those sides. So are you referencing like different indexing options there, or you're or
Correct. I recommend the customer to send the file, but
Mhm.
so I just had to mock one up, and essentially this is what it looks like is something similar to this, where there's some pockets on the side.
Yeah.
So what I have right now is the part on a four-axis job. I have a 0 on center line, okay? And what I want to do is machine the part. So do I need an index system to start machining?
Um, I would believe so. I mean, unless you have the open pocket setting that picks, well, since you've got from looking at it, it looks like you have the Z axis pointed
Correct.
specifically to where you don't need to index to start.
Correct.
Yeah.
Right, right. So if your Z is aligned with your part, technically you can just start loading toolpaths, right?
Hmm.
So I think he did something like this where he just selected the whole body and then he loaded one of these strategies, right?
Yeah.
So let's get an advanced rough in here. All right. Again, I don't know the size of the part, so the tooling doesn't really matter at this point, and even some of these settings, because we can always adjust these, right?
Yeah.
Okay. So right now, there's all this toolpath on the screen.
Right.
What do I do to fix that? Because I don't he probably turned the profile down already. Like you figure most
Yeah.
shops have a mill and a lathe, right?
Hmm. Right.
So he probably turned the profile down already. What's a way that we could represent the stock that way? Like right now, it's a cylinder, but we actually turned it down on the lathe first. What would we do to do that?
What I would think of is creating the revolved part to represent it after it's been turned, to use that as the stock. Let the software understand that's the remaining stock to be machined.
So in this case, we're in SolidWorks, right? So we're just going to pull the CAD tree up, suppress those features, right? We're going to come back to the cam and we'll look at our wizard again and we'll select the solid body stock option.
Yeah.
Okay. So essentially, we already had the part turned and we just used the CAD history tree to help us uh, define the stock, right?
Hmm.
Okay. So now that we changed the stock, what's going to be different?
It will create the toolpath based on just the stock remaining that you've now defined.
Well, what do I have to do to update the toolpath? The toolpath is all over the place still. It didn't just fix it.
I believe you should just need to right click on the feature, update geometry, and update toolpath, right? Or do you have to reselect the geometry possibly?
Well, I think it's a good question. Here we didn't make any change to our selected geometry, so we probably don't need to update this, right?
Hmm.
Um, but we did make some change to the stock. I think inherently, if you make a change to the stock, it understands it at this top level. So I believe if we just recompute here, that it will update for the change in stock.
Yeah.
Okay. All right. Now we're cutting over here and we're cutting over there. What are some problems you see, Eric?
It looks like from where I just left off on my screen, we were talking about the entry options. It looks like it's plunging down into the stock where normally you would want to start from the side.
Okay, so how the tool entries,
Yeah.
that's a good thing. Okay, what about these floors here? Uh,
Uh,
So
yeah, it looks like it doesn't get down to the floors.
so we kind of want to get down to the floors. How do we do that?
That would be on the page that I just left off. The options page, you have a machine flatlands option, which is just below the rest roughing.
Okay. All right. So if we turn that on and then what do we do to make it change?
I believe that should be it, right? Once you compute it, it should hit the flat any flat surface on your part
Okay.
file.
I think the
Is
key
that right?
there is if we just hit finish, it's not going to change anything. We're going to have to update it, right? So to update it, we need to recompute it. So we made some changes to the feature. Let's go ahead and recompute, and now we can see that it's cutting down there on that flat,
Yeah.
right?
Yep.
Okay. Now you were talking about how it comes into the part here, right?
Mm-hmm. Mm-hmm.
So what do we do to see how do we see where the tool is? Right now I have my part and I have my tool path. How do I see where the tool is?
Yep. So you can right click on the operation in the cam tree
Well,
and go
what's an
to
operation? Is that
um,
this thing?
no. So A little hard to see, but no. So under your feature where it says mill three axis, uh,
Okay.
an operation would be the very bottom option that you just highlighted there for
Okay.
uh, three axis rough. And then if you had multiple operations in that feature, which is a feature is a group of operations.
Hmm.
So once you expand that feature, you would have multiple operations that you have created. Since you just have the one roughing, that's your operation under the feature.
Okay.
So you'd right click on that operation where it says advanced rough, and you'd go to backplot to be able to see the tool, the entry of the tool, and be able to play through it with your CAD geometry on the screen.
Is there any other things that are important to talk about here when we're talking about backplotting?
When talking about backplotting, I mean, you can play through the whole toolpath of the operation. You can see the start point, and you can see the point of the tool at every step.
Okay. So some of this stuff down here that's pretty useful is this location stuff too, right?
Yep. Yep.
So the location, especially as we move up in 4 and 5 axis, if the tool has a different orientation or which way it might be tilting, we'll get a vector location here, right? And
Mm-hmm.
then we also have the type of orientation, the start point, and the feed rate information down here as well.
Mm-hmm.
Okay. So I think in the last 3 versions, we've seen some updates here to be able to isolate some of the different tooling information as far as being able to turn off the holder or what have you. Okay,
Right.
so I definitely would agree with you. This is a great way for us to approach, how we're going to view what's going on here. So
Mm-hmm.
you're talking about the different ways you can change how it comes into the part.
Right.
Okay. So
And
what is that generally called?
so, looking on my side here, that's under the leads page. You have your entry options.
Okay. Okay. So you got a couple that are here. You have center cutting, you got ramp, plunge, ramp. So these are going to be all your different options to adjust the way the tool comes in, right?
Mm-hmm. Mm-hmm.
Okay, very good. So what I want to do here is I just want to address this customer who's in the group here, and I hope he's watching the training today. And then I'll give it back to you, Eric, to pick up where you left off. Um,
Okay.
Essentially, here my big takeaways are if I'm on a fourth axis and I want to machine on the different faces, even though the Z's align, I'm probably going to load an index system to begin with. Um, so I'll load an index system, and essentially that's just going to clock the part.
Mm-hmm.
From that index system, what am I going to pick to reference off of? Initially, I may just pick a plane. It may be
Mm-hmm.
easy to just pick a plane selection in order to align your Z.
Mm-hmm.
From there, we're going to load in a strategy child to that index system. Okay. Now, because we're using 3D toolpaths, we can use our stock and our workpiece in order to control where the toolpath is being generated. And
Mm-hmm.
then we can use different settings within the software to drive how the toolpath is being run. So in this example, I'll set a depth greater than what I expect the pocket to be.
Mm-hmm.
I'll set a step over amount. Okay. And then on my options here, I'm going to choose machine flatlands. And using a strategy like this, it should just attack that floor and that's it. Again, depending on the depth of cut. Now, the other thing that we see here is even though I have access to this geometry over here, I really only want to target on this face here. So how can I get things to go away? And that's using your advanced allowance. And this is very important for fixtures and other things that you want to avoid. We can go advanced. We can say add geometry. We could pick different faces that we want to stay away from. Okay. We can give it an amount that we want to stay away from those faces. Uh, some amount here. All right, and this is also commonly called avoidance. A lot of times when you make this adjustment, it yells at you about the clearance plane. So whatever value you add, you want to add that value here so that it has the room to clearance. But again, so in this case, it's roughing in that area because it's staying away by that amount. But it's one way in which to control this. Now, sometimes it makes more sense to just keep it 2D. And in this case, I think that might be one of them, especially because this is just a pocket. So we'll
Right.
just talk about pocketing real quick. We're going to just select this face here. There has been adjustments to being able to understand open pockets in all systems. BobCAD, the standalone, BobCAM for Solidworks or BobCAM for Rhino. BobCAM kind of led this, had the capability for a while. We should be able to just select that face there and have it come in and machine that. Okay. There are some advantages of the 2D or the 3D adaptive over the 2D as far as controlling these link back moves. You'll see in pocketing currently under links, there's no option here, but when we're in the 3D routine, we'll see there's an option that we can use as a threshold value to keep the tool down. This is very important, especially if you're trying to minimize up-down motion. So when we're in adaptive, you'll see this threshold value here. You'll use this to keep the tool down,
Mm-hmm.
okay? Once we have one index system in one pocket, we have a couple of different approaches. We could repeat the process, or what we could do as a pattern. Patterns are much better to use today than they were in the past because you have more control over them because of the new operation manager. In this case, I'm just going to come in here and load a toolpath pattern. We're going to do an array. I'm sorry. Let me see if I do this right. Oh, array. No. Rotate. 3D. This is going to be 93. Okay, so we can just use a simple pattern like that. We've been able to do patterns in the past. What's new and different is the operations manager, which is going to show each of the pattern instances. And what's neat about that is then you can turn individual ones on or off, or you can reorder the order of operations. This is super control for 4-axis. Great stuff. The reason why you want to be in these training events to make sure you know about these new features. Um, I'm going to give it back to Eric. So I'm going to stop sharing my screen here. Eric, if you're ready. If you
Yep.
guys have any questions, I'll be in the chat. I'll try to share links that you guys can reference later. Other than that, I really appreciate your time. If you'd like to come see us here in Florida, we do have our first in-house advanced training. It's right here in Tampa in the spring break. Who should consider if you've mastered the fundamentals, this class might be for you. Call us for more information. It's at the end of this month. Thank you so much, guys. All right, Eric, back
Yeah,
to
thank
you.
you, Al. Thanks, Al. And also wanted to ask you about. Well, I mean, there's a question in the chat. I don't know if you wanted to answer that. There's an undercut question with Mark. If you wanted to answer that in the chat, or if you wanted to answer that on your screen.
I think I'll answer it in the chat. I got to
Okay,
handle a couple of things real quick. But
sounds
yeah, if
good.
you can, let me see if I can make it so you can share your screen.
Okay,
But you gotta
let me try
set your
here.
screen.
Am I good?
You're good.
Okay, cool. Thank you, Al.
You're welcome.
Um, So yeah, a lot of good stuff there as well with the toolpath pattern, being able to create, like you were saying there, Al, multiple instances of the toolpath around a cylindrical part very easily, being able to uh, change the order of operations there. Those are some new features there in V10 that can be really useful. Um, Getting back where we left off here with the part file, we did the facing and we're doing the 3-axis cutting. A lot of the stuff we just looked at, machining flatlands is an option there. So with this part file, with this example, we can machine flatlands on the top here of this boss. And then down at the bottom here as well, I can explain this a little more too with the flatlands option. The reason why this is useful is we have a go back to this page here. We have a depth of cut of 200 thousandths every time. So if this bottom floor here is not at 200 thousandths or 400 thousandths or 600 and so on, uh, if it's not at the same level of every depth of cut that we're setting, it's just going to skip that surface as we just saw on Al's part file. So that's where this machine flatland setting is very useful. It'll come back with an extra depth of cut to follow along any flat surfaces. Next is all of the settings that we saw before with linking, our gauge check page, advanced feed rates, and MDI. One other option or one other setting that we can see here that's newer in BobCAM for Solidworks in the past couple versions would be our adaptive feed rates. We have a radial chip thinning option and a volume-based option where I can set a minimum and a maximum feed rate here. So it's going to be based on the percentage of the current cutting feed rate. So it'll go all the way down to 10% of the feed rate that I have set. And what this will do is kind of like a look ahead option in some of the machines where the tool, you can see here with this sample here, when the tool is getting into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load. And that can reduce chattering at the machine. So based on the volume that the milling tool is milling the material out, it's going to calculate and set a smaller step over based on the volume that is cutting and keep a constant chip load. It's basically the setting there. Then we have our MDI page again, and then setting up the tool for the steep shallow operation. We'll go back and we'll use, instead of a flat end mill, we can use a ball end mill. So we'll go to our tool library. And I'm just going to use a ball end mill from the tool library that I have. I've got a 1/2 inch ball end mill here. We can make it smaller if we need to. But yeah, we've got the 1/2 inch ball end mill for this one. You can see 1/2 inch diameter, 1/4 inch corner radius. Our next page, some tool axis control options. This is going to be 3-axis. If we're doing this steep shallow, this is kind of similar to the toolpath pattern that we just saw recently. With the 4-axis method, we can set a step angle and create an array of the toolpath around the part as well with this tool axis control method. So next we have the settings for the steep shallow operation. So with the Z-level finish, normally it will just follow along the curved surfaces or along tapered walls of the geometry and will not get to the flat areas like we see here. If we want to clean up any flat areas with this operation, that's okay. We can see here with the Z-level plus planar, so it'll do a Z-level finish plus a planar along any flat areas, or a Z-level plus equidistant, where it will do a Z-level finish and then an equidistant toolpath along any flat areas of the part. Other than that, if we want to start from the top going down, start from the bottom working up. Our next page, we can set a depth of cut here and a step over. I'll do it a little smaller, maybe 20 thousandths. The step over and the depth of cut. Leaving 0 allowances since this is the finish pass. Entry options here. And other settings for our rest machining and gauge check, advanced feed rates, MDI. I'll hit compute. It'll take a few seconds to compute this toolpath. It's going to be computing the roughing and the finish pass along the index that I set up. And you can see the roughing is basically So yeah, as we saw here with the different operations under the feature that I created, we have an advanced rough and the steep shallow. I can highlight each one to see the tool path exactly for each one. I can blank each operation to the left of it with this icon of an eye to show or hide it. So I'm hiding the steep shallow operation, and we can see there's almost no toolpath for the roughing. And that's because of the, well, for one thing, because of the depth of cut and step over amount. So I'll bring that back to 100,000 step over, 100,000 depth of cut. So we'll get a couple more passes in here. And we can also see that it's not going any further down than right here. And we'll go back to that back plot option and kind of just step through here. I can move the progress bar all the way down. Maybe back it up a little bit so we're at that depth here. So we can see that with a boundary selection, the tool's not able to fit any further down than where I have here. So we do have a different setting once I turn off the boundary. So I'll right click on the boundary and remove, and then recompute the toolpath. Oops. But this is going to compute for a while because it's going to, I believe it's going to compute, yeah. So as we saw in the previous part file with Al, it's going to create a lot more toolpath than we want. And to remove that, instead of creating a boundary from the top down containing the toolpath that way, we can contain it from a Z level. So we can contain it at a certain depth. And we can do that by right-clicking on the feature, going to Edit, going to our parameters page. Down towards the bottom, we have this user-defined option under depth options. So we'll select user-defined. We have our top of job of where we want to start the toolpath at. And we have this bottom of job where we want to end the toolpath at. And so I'll select a surface edge or a certain point at the depth I want it to end at. It says negative half an inch from the top of where we're starting. And then I'll hit compute again to recompute the toolpath from there. There we go. Now we have the, we also have the toolpath where it's going to start from the outside of the stock here, work its way in with the side of the tool. I can step through and see it starting from the side of the tool and working its way in as that side roughing routine. And it's also just going to get down to the, so there's no boundary here to contain the toolpath inside of a certain area, but there is a boundary in relation to the bottom of job where I'm setting the depth here at this surface here and not going anywhere further than that Z level. It's doing the multiple passes at 100 thousandths every time. And so we'll close out of that. Take a look at the steep shallow. Oh, the steep shallow, I didn't set the bottom of job for that one. So I'll right click on the feature, go to edit. I'll go to the, let's see, under the parameters page for that one, I also have to select the bottom of job for that one. Instead of hitting compute, which would compute all of the operations within the feature, I can hit finish, and then I can right click on the certain operation under the feature in the CAM tree, hit compute, and it will only compute the steep shallow operation. I don't have to compute the advanced rough again, which will just have the same exact toolpath since I hadn't made any changes to that one. So that's about it with those operations there. You can take a look at some of the other features here. Yeah, I mean, we could do a couple other, let's see. Yeah, we'll run quickly with the couple indexes here, and then we'll get into the rotary operations on the next part file. So right click on, no, sorry, we got to create the other 3 planar faces by going to Features, Reference Geometry, Plane, selecting the 3 points here. Now we could maybe, okay, so I'll create a plane right here for the pocket. I'll create a plane right here for the holes. But I'm not going to do the facing operation under all of these here. There we go. Alrighty. So we got those planes set up how I need to. So to start with, I'm going to right click on this index system, the facing that I started with. Now we could do a facing under the index system of all of these, or to save us some time, we can right click on the index system like we just saw. Go to additional functions, go to add toolpath pattern, go to rotate, and that's our 3D option. It's going to be 360 divided by 5, since I've got 5 different locations there. That'll be 72 degrees each time, and I'm making 4 additional copies. Click OK. It doesn't have the rotation angle around here, so I just need that for my toolpath pattern for it to rotate around correctly. From our feature tree, let's see, we got the 3D model. We got from the origin point. What I essentially want to do is just create a line going through the rotary axis. So I'll just kind of sketch something here. That would be our line of rotation there. And that's the easiest way to go back to the toolpath pattern. And instead of having to understand what the, or I guess you could say, instead of typing in the coordinates, because that would reference your origin point of your SolidWorks part file. So that changes every time, so it's hard to know what the coordinates are for each one. That's why it's easier to just create a line like this. Pick the start point of the line, pick the end point of the line, and those are the coordinates that I need to set up there for my toolpath pattern for a rotate 3D option there. Now we can see that it is creating this one here, this facing operation for this one. I believe maybe I could just do 3 copies instead, because it's, nope, it's going the opposite direction. So I might be able to just do a negative 72 here. Yep, and then it'll start here, it'll go to this one, and then go around and skip this one. Or just to kind of showcase that feature again of the operation tree, I can make that additional copy that I don't want this facing operation, because the facing operation will remove this area here of this boss for us. We don't want that. So we'll go to that operation tree here, and we can select the facing operation, which is the second one here. I don't want to post that one or simulate it. I can turn it off. Yeah, I can turn it off here, but I don't want to see it at all even in the milling job. So I'll go back to the toolpath pattern, double click on it. I'll go to negative 72 degrees and I'll make 3 copies. So that'll remove that toolpath for that one. Yeah, as Al was showing us, doing that toolpath pattern around instead of making a planar face for this facing operation, I can easily just use the toolpath pattern for it. Making a plane, making an index system, I can just do the toolpath pattern and rotate that toolpath around the part file. Next, we just have to do the pocket here and the drilling operation here. So I'll do the pocket since I just made that plane. Right click on machine setup, additional functions, and add index. Select the index and select the plane for the index. Click OK. Right click, go to mill to axis, select my geometry. Again, when selecting geometry for a pocket or containing the toolpath inside a boundary, I can just right click on a surface edge and click select loop. Now it's selecting the loop of the side surface here. I just want to click this arrow and then it will select the loop of the top surface for my surface edges around here. Click OK. I'm just doing a pocket. And to make things easier, we'll take out the profile finish. We'll just look at the pocket here. Set up our tool. I don't want a ball end mill. I want a flat end mill. I'll use the, yeah, I guess we could use the 1/2 inch flat end mill. Might take some time with this large pocket, but that's okay. 1/2 inch flat end mill. Next page, our different cut patterns. We got our morph spiral and adaptive roughing. We'll take a look at the morph spiral for this one. Set our step over amount. Let's see. 0 side allowance, because we're just doing this pocket. We're not doing a profile finish to clean it up. And we'll do, let's see. Oh, we don't have a depth, do we? So we'll go back to the feature. Okay, there we go. Total depth is still at 0. So I'll pick the bottom of the pocket. It's going to be 1 inch. So I'll go back to that parameters page where I'm setting my multiple steps, multiple depth of cut there, and we'll do a 1/4 inch depth of cut each time. So 4 number of cuts there. Everything else looks good. Our lead-in page, our machine sequence. If we're doing multiple pockets, we can set a sorting order of those if we want to sort them ourselves. Linking, advanced feed rates, and MDI page there. So that's our pocket. And then the drilling operation. If we had, so this is in the link that Al posted in the comments page here in this video, offering different options when it comes to drilling for 4-axis. This one only has one size of holes around the part, but we can we can show this feature anyway in case there was any other holes on the part file for Rotary. We can make this very easy. Instead of creating the plane and creating the index and selecting the holes here, we can right click on the machine setup and we have a hole recognition page. So this is the third option down here under your machine setup, selecting hole recognition, selecting the solid model and clicking OK. It will pick up, no holes were found. Maybe it doesn't pick up for, or we could do it, hole recognition might be just for like 3-axis part instead of Rotary. But for this one, we can take a look at another option would be under the machine setup. We have the mill drill hole, select geometry. So currently, sorry to rotate this around so much. Okay, so currently under the machine setup, as we discussed before, we're just looking at it up and down like this with the z-axis of the machine setup under the standard drill. But then we have this cross drill option. So then it will just, this is for our 4-axis settings here where we can pick a hole here and it will understand the geometry there around the rotary axis for cross drill settings here. See if it picks that up. So I'll reselect the geometry. Can pick the surface. I'll hide the solid, so I should be able to window select. No. There we go. So I can select all of these holes here. Yeah, we can select. I mean, if we had the sketch, it would be much easier to just select the sketch from the drop down here. I don't believe I have that now. But what we can do is we can select. We'll clear the selections and we'll just select the sleeves of the first row here of all of the holes. We could even do just the first row, and we could do a toolpath pattern if we wanted to do that too. But we'll select the first row, select OK. Let's see. Maybe I have to select. That's okay. We'll just do an index here. Right, did I have the index? The plane. There you go. Yeah, so we go back to the plane, and we can go to indexing from there. Again, we could do the hole recognition, or we could do the cross drill option, or we can right click, additional functions, add index, and select the plane. Here we want to reverse the direction. That might be causing something there with the index. And then, so right click and go to mill drill hole, select our geometry. Again, I'm just going to select I'll select the sleeves of the holes here. You can select the sleeves of the holes for drilling, and you can also select surface edges for holes for drilling operations. There we go. Now it's picking up geometry. Looks like I need the whole selection there. Okay. After that, we can pick the total depth. We can do a center drill and a drill operation. We can pick the sorting order of the drilled holes, set up our center drill, and for every drilling operation now, including center drill, chamfer drill, reaming, boring operations, we can do a single depth down, peck, or fast peck down into the material there. Then we can set up our drill. Again, peck or fast peck down into the material, and then hit compute. And so from there, show the solid there. From there, we can, let me reselect the geometry for the 2 holes there. Hit OK and then recompute. Here we go. We'll take a look at so from there we can compute or simulate the toolpath as well by right-clicking on milling job, going to simulation. We've taken a good amount of time with the indexing feature here, and then we'll take a look at the rotary and then wrapping group next. So here we've got our estimated cycle time. We can run through it. I believe it's going to sort based on the tool first here. So it's going to do all the facing operations first, and then it's going to do the 3-axis roughing and finish, and then the drilling and the pocketing as well. So right now we can see that the tool is kind of rotating around the stock. That's not as realistic as we want it to. To make it a little more realistic, we drop this down and select tool. It'll focus based on the perspective of the tool to be able to simulate it that way. We can see the stock rotating around and the tool machining it out there. So this is the 4th facing operation, the final one there, and then our 3-axis toolpath. Slow it down a little bit there. So it's going to be set at 100,000 step over, 100,000 depth of cut. Move it along a little faster there. Go to the next operation will be the pocket operation with that same 1/2-inch flat end mill. Same tool from the 3-axis roughing operation. And then the 3-axis finish operation here. Get down into the pocket and then along the tapered walls as well. And we go back to the workpiece stock so that it's not jumping around there. There we go. Then once everything is done, I mean, we can see there's a ledge here, and that's because of the tool radius is not able to get anywhere closer than we are what we're at here. We could use a flat end mill to finish this bottom floor, but then we'll need a smaller tool to get into the corner a little bit better with the tapered wall. That's a good simulation to make sure everything is cut to size before we run it on the machine. Once everything is done, we right-click on the milling job and go to Post. It'll generate the G-code for this here. I typed in this is a test here in the comment section, so that's where that MDI came into play. But yeah, here's the first facing operation with a 34 degrees, 34.971. Then we go to the next one is A106. As Al mentioned earlier, we could start with our machine setup pointed at the first face here, and then we could do A0, and then it would be a little easier to determine, A0 and then A72 and then A144 here. But since we started with the z-axis pointed to this peak here, it is going to rotate backwards. no, sorry, it's actually just going to rotate forward around a A34 and then A106 for the next surface. Next is A178. Next is A250. And then next is a negative 37. Is that the right one? Okay. So that's the last one there for the 3-axis toolpath. And then once it's done with the 3-axis toolpath, all of this here. That is a lot of lines of G code. And then after is going to be with the finish tool, the steep shallow operation. Same A-axis location. And then we'll go through the 3-axis finish operation. Down to the very bottom where you have your drilling operation for the center drill. And you've got, let's see, A106 and another A106 for the final drilling operation there. So, yeah, once everything looks good with the A-axis rotation, we can save it, put it onto a flash drive, and send it over to the controller. That's done. That's it with the indexing features here. We'll take a look at a couple other features for the 4-axis standard. We'll look at Rotary next. So open a new part file. So we have a part file with a cylindrical shape like this here. And we just want to follow along. It's basically just a revolved surface through. We're not going to be milling inside of it, just the outside surfaces right here. And could be good for furniture, table legs that we have customers with, something like that, something continuous. Some customers don't have a lathe to be able to turn this on. They just have a 4-axis rotary. So if you wanted to do a quick roughing, you could also just do a quick roughing of this here with a mill with the ball with a flat end mill, and then a finish operation with a ball end mill. With this one, we're just doing we're doing 2 operations. And yeah, that's what we're doing with a roughing with a flat end mill, and then finish with a ball end mill. And we begin this rotary operation by setting up our stock. It's a little bit larger than the workpiece we've got. Defining our workpiece, defining our machine setup. Again, is the x-axis will be our axis of rotation, the a-axis going around the x-axis. And then we right-click on machine setup. We go to mill 4-axis rotary. Select our geometry. So I'd select these surfaces here. No boundary for this one. Set where we're starting at the top of the stock. Rotary operation. This advanced rough and advanced finish is in the Mill 4-Axis Pro that we'll get into next week. And this is a good point of explaining the 4-Axis Standard versus the 4-Axis Pro. If we look at the back plot here, the tool will either stay constant to pointing at the center of rotation, or we have that side shift option where it'll start to the side of the stock, but it'll continually be at that location. It will not be moving in the y-axis at all, back and forth here, while the part is being rotated. It's just going to give you your z and x moves and your a-axis rotation moves. To move simultaneously in x, y, and z while it's rotating, that would be in the 4-Axis Pro. and that's something we'll get into next week for the 4-axis Pro there. So 4-axis standard, we're just doing a couple rotary operations, one roughing and one finish. Setting up our 1/2-inch flat end mill here. Either if we're going around the stock or along it back and forth. We have a couple other settings here. Zig, so it'll just go, so it'll just do one pass, step over. Zigzag, where it'll go back and forth. Or spiral, where it'll spiral around the surfaces. Just continuously cutting there. A couple other options here if we want to cut clockwise or counterclockwise. And then also if we want to cut all the way around the cylinder, or if we want to cut interval. If we just want to select a certain section that we want to machine, we can select the certain angle where we're starting at 0, and then if we wanted to do only half of it, we could select 180 degrees here. Then our next page, setting our step over here. And just like with the cut interval option, we have a start and end point along the cylinder. So if we want to start at a certain location and then end at a certain location, not cut anywhere further past the cylinder, we can set up those limitations as well. Then we have our multiple passes option. We're doing 3 number of cuts at 100 thousandths spacing between each cut there. Our entry option, linking, gouge check, advanced feed rates, and MDI, just like in the previous operations with indexing. We set up our finish tool and set up those same parameters of spiraling around, step over, and all those options as before. So now we can either backplot from the operation in the cam tree, or we can right-click on milling job and go to simulation. Okay. So again, tool's rotating around the cylinder. If I don't want it that way, I can change it from workpiece stock to tool. Now it's getting into the stock there for the first roughing pass. Looks like it's doing a lot of air cutting at the top there. And then what it just did is it retracted the tool. So once it gets to a certain rotation angle, in this aspect, the limit to this machine is 10,000 degrees. Once it gets to that 10,000 degrees in A, the tool can retract and rewind the stock so that it doesn't hit the limit and end the operation. It'll rewind the stock back to negative 10,000 so that it will go back to negative 10,000 and then start doing the positive direction of rotation again, so that you don't have to rewind it yourself. You can just have the tool retract, rewind, and then go back down once the stock has rewound around the rotation axis there for your rotary table. So yeah, it looks like there's some air cutting right here where we don't necessarily need to spend so much time on the surfaces that are already finished. So we can go back to that page and we can go to this trim to stock option. So it's going to trim the tool path anywhere that we saw that was air cutting. We recompute that operation and it'll get rid of some of the tool path here at this area and here at this area. So you see a lot of the tool path cut away, trimmed away, you could say. Cut down on cycle times a lot there. So it's just going to rough in the areas that it needs to. Do the second pass. Do the third pass. And then the finish pass. So this could be helpful for woodworking with furniture, table legs, things like that. Um, and for any customers that don't necessarily have a lathe to turn the stock down with this, you can use a milling tool and use the rotary table to rotate around to mill this out. That's in our rotary operation. And then we also have a wrapping group option here. So with this here, I actually just didn't do any of the holes around the stock here. We just are focusing on the two pockets around the cylinder for the wrapping group. Uh, and to create a wrapping group, we basically just right click on the machine setup, go to additional functions, and it's in the same area as you have your index system. You can add wrapping group. It's actually the option right under add index, add wrapping group. We can tell the software whether the geometry is wrapped around the cylinder already, or if it's not, we would leave this box unchecked. So, for example, if there was a design that we want to project the toolpath around a cylinder and the design, the logo we want to do an engraving of, for example, is still flat, we would just uncheck this box. We could select the flat geometry, and the software will project the toolpath around the cylinder for us automatically. But since this geometry is already around the cylinder, the pocket, we can check this box, wrap geometry. We can use our stock diameter, so it'll create the toolpath around the diameter and then work its way down with the depth of cut we set for the pocket. So within the wrapping group that I have set up, I can right-click on it and go to our different milling operations. So I basically just go to Mill 2 Axis. That's what I have here in my feature with my pocket and profile finish. And it's under the wrapping group. I set my top of feature, my total depth of the pocket. This is the preview of the two pockets if it were flattened out. We're just doing a pocket and a profile finish. Kind of skip past the posting pages there, set up our tool. It's a it's an 1/8 inch flat end mill for the pocket. Set our pocket pattern that we're using. We're just pocketing out, starting from the center, stepping over the whole time. Setting 15 thousandths for the finish pass to clean up. Doing 2 number of cuts, so 2 different depths there. Plunging down, setting our machine sequence, closest sorting, feed rate, advanced feed rates, and MDI page. Set up the finish tool. Set up the compensation for the finish pass. Just doing 1 step down with the finish operation there. And that way, with all of those settings, I mean, it's very straightforward. We're just creating what's called a wrapping group under the machine setup, and then doing a 2-axis feature under that wrapping group to project that 2-axis cut around a rotary table for a 4-axis milling operation here. Very simple, straightforward. Doing the second depth of cut with this pocket, and then going to the next pocket to pocket it out, and then a profile finish around the two pockets after. So essentially you can see it, the tool is just going down in Z, and then it's moving back and forth in X while the part is being rotated around the A axis rotation to give us this pocket operation. The nice thing about programming for 4-axis is it's the same workflow, the same exact workflow as if you're doing a 2-axis feature. You're just doing it under a wrapping group for this one. Same goes for the indexing. It's the same thing as if you're doing a facing operation here. You're just you're just creating an index first and then creating the tool path for it. It's actually this one. Creating the index on the surface and then creating a 2-axis facing operation for the indexing. I'll just hide that for now. And then the 4-axis rotary is very straightforward, just selecting the geometry and it will create the toolpath around a cylinder for you automatically. And then getting back to the wrapping group, again, just setting up your machine setup and then setting up a wrapping group from the machine setup and doing a 2-axis feature from the wrapping group. You're basically just doing a pocket and a profile finish, and the wrapping group does its job for you to wrap the toolpath around the cylinder for you. Those are the 3 basic features in the 4-axis standard that will help you get all of the 4-axis toolpath operations that you need. And kind of as a jumping off point for next week for the 4-axis Pro, that is under mill multi-axis. And we can look at these different surface-based toolpaths where the tool, even with a rotary table or with rotation of the spindle head of the milling machine for 4-axis Pro, the tool can do any undercutting milling operations. It can also move the tool in X, Y, and Z while the part is being rotated. If we go back to that rotary operation, we can take a look at where there is a side shift option. So right now it's at 0, where the tool is going right down to the rotary axis and the part's being rotated while the milling tool is removing the material. We might want to do a side shift of, we could do a side shift of 1/4 of an inch, or maybe of a 1/2 inch there. And so the tool will shift over to the side of the stock or the side of the rotary axis there automatically. And then it will be stationary in the y-axis. It won't move back and forth. You'll see that the tool is a 1/2 inch over. And then, so when it's being machined and the stock is rotating, it's going to be rotating around that way and milling with more of the side of the tool there instead of going straight down to the rotary axis. This is basically the only Y movement you will see in the 4-axis standard, where the 4-axis Pro can move back and forth in Y while the part's being rotated. So if you're using a ball or a bullnose end mill, usually the example that I give is a camshaft. The tool can follow along the surface in X, Y, and Z while the part's being rotated to follow along the cam lobe of the camshaft. So that's the side shift option there. That's under the patterns page to be able to use the side of the end mill a little bit more. And like we were saying, if we wanted to get into using the side of the tool to maybe mill out, let's see, to maybe mill out like the top surface here for the end mill, it would basically be setting up an index. So that would take some time to set up an index perpendicular to that surface, and then you can use a profile operation. So what we could do is we'll blank out all the toolpath. I would be, let's see, or what I could do is I could start with the machine setup that way, kind of get a good understanding here. We could go to the machine setup, create it to where the z-axis is pointed parallel. So I'd highlight z-axis, make it parallel to the line of the yeah, so it'd be something like this here. So the z-axis would be pointed down, and then we can use the side of the tool to mill out that area with our z-axis pointed parallel to that direction. So that's the basic way of doing it here, selecting our geometry. I can just do this here and then make a lead in and lead out far enough to mill that out. I mean, I could even do the arcs here for my geometry, or just make a line in SolidWorks, sketch a line going across to do a profile operation. I could say that we're starting here at this top line, and maybe we wanted to start just at or end just at the bottom here. That way we just do a profile operation. We'll do a profile rough and finish because we can do multiple passes down it. Set up the tool, just a flat end mill. And we're doing multiple steps, and we'll do 1/8 of an inch depth of cut each time, or number of cuts, and then a finish pass with, I suppose, the same tool, 1/2 inch end mill. Yep. And then, yeah, just doing one pass. We'll hit compute, and that way the tool will come down, and then do that. Yeah, if we don't do this for the first operation, if we have to do that later on, we don't necessarily have a flat surface to define a plane for the index system for that here, unless we use this inside wall for an index. We could do that. That'd probably be the easiest way to go about it. Or to make a surface perpendicular to this line going across. But yeah, I mean, if we were using the machine setup as what it was before, and we're doing many milling operations, then indexing to this location, say we've got our z-axis to what it was here, we'll change the z-axis pointed to this location, and then we're indexing across to, and then we're indexing at that location later on. Yeah, I don't think that these are parallel. If they are, then you could use that. You could use this as an index, and then just go down from this location going down. But no, I don't. No, those aren't parallel or perpendicular to each other. So what you could do is, if this is just a straight wall, you could go to additional functions, add index. Actually, yeah, again, features, create a plane from here. So 1, 2, and 3 points. Then you have your index system selected as that plane. And then you can go into the index system, select your geometry. Would be the same geometry as we just selected before. Mill2 axis, select the same geometry there. It's just one line. You're picking it from, let's see. So you've got your index in this direction here, I believe. Right? So you'd be picking it from the top here and working your way down. Total depth of a 1/2 inch. Use your same tools there. 1/2 inch flat end mill. Multiple depths of cut. Use the same tool. Hit compute. And there you go. So a couple different options there. You've got your machine setup where you could get it. You could get the z-axis basically perpendicular to this location, so that you can do that very easily. Or if you're doing many different milling operations and then you decide later on you want to use the side of the tool for a profile cut like this here, you could easily create an index system perpendicular to that location, basically, which would be this plane that I just created, and index from that location. So now you can see your z-axis right here is pointed up and down, and the tool will follow that z-axis coming down and using the side of the tool to do a profile operation along the flat wall there. So a couple different options on how to create the using the side of the tool. Yep, I agree, Mark. Saying the side cutting makes a nicer finish. So those are the options of how to create using the side of the tool, making a nicer finish with that. Using the side of the tool profile cut to finish anything along the part file there with the 4-axis with indexing. Yeah, and if you guys have any other questions, please let us know in the chat. That's pretty much the end of the webinar for today. Just to recap, we went through the rotary operations around this here. See if we still have the toolpath. Yeah, so we went through indexing on each surface and doing a facing operation on each side, drilling the holes, doing a pocket, and doing a 3-axis toolpath after indexing to this location, and being able to go in, do a roughing and a finish operation along the different areas of the cylindrical part file here with the rotary table. Going through indexing, going through rotary operation. So kind of like turning down the stock here with roughing and finish operation, but with a milling tool here to rough out this area here. Also being able to use a side shift to use the side of the tool with the end mill to rough and finish this this part file here with a rough and a finish tool with rotary around a rotary axis with a rotary table milling machine. And then we also went through a wrapping group to do a pocket and a profile finish around pockets around a cylindrical part here. I would say that's about it with 4-axis standard today. Next week we'll be going through the Mill 4-axis Pro V10 BobCAM for Solidworks. And I'll just check if you guys have any questions. Please let us know. And if you guys do have any questions after the webinar today as well, you can ask us either calling us. Our tech support line is 727 489 0003. So ask any questions that you may have. We're open Monday through Friday, 8 a.m. to 5 p.m. Eastern Time. Again, the phone number is area code 727 489 0003. And then our email address is support@bobcad.com. So you can either call or email us after hours as well. Send us any part file that you're having issues with. Ask any questions that you guys have. Um, any question that you have moving along with programming for 4-axis or for anything else with BobCAD. And yeah, we'll finish off. Seeing if we have one more question here. Side of mill cutting to make a cone taper. Imagine a concave radius cutter with a radius of, say, 1 inch. 4th axis. Yeah, so using a cone taper with the side of the milling tool there, Mark. Let's see. I'm thinking that could be possible in Rotary. We have the side shift option. We also have. Let's see. I know we have a conical option. Or it might be in the Pro. Let me check in the Pro real quick. So we have conical machining, and you set the cone angle here, and it seems like that would be more of a 4-axis Pro question. With this conical machining, that's what it sounds like with your question there. Being able to use a side shift and being able to go inside of a pocket, doing an undercut option, and those kinds of settings here. We can select a line or select the actual cone shape and be able to do that type of machining that you're referencing there. So a lot of that kind of programming is going to be done in the 4-axis Pro, and we can take a look at that next week and kind of leave off from there. Is a cone switch new? The cone option, that is a newer option in the 4-axis Pro. I believe it started in either V8 or V9. But yeah, it is definitely a newer option because we have the advanced rough and the advanced finish in Rotary is a newer option in itself. So we'll take a look at that conical option in the 4-axis Pro, as well as other features in 4-axis Pro next week, where the tool can move simultaneous 4-axis cutting. And that's kind of where we'll leave it off today. If you have any other questions with that or anything else that we went over today, please call or email us. I'll give that information one more time. So our email address is support@bobcad.com. And our phone number is 727 489 0003. Thank you guys in the chat there for following along. Thanks, Mark. And thanks, everyone, for viewing the webinar today. And hope you guys have a great rest of your day. Thank you.